Okay, this week's lab is to observe the process of diffusion. In order to execute this lab, I have gathered a teaspoon of cornstarch, 50 mLs of distilled water, and I will be using 1 ml of iodine. First, what I'm going to do is take my teaspoon of cornstarch and mix it with my 50 mLs of warm water. This is going to help the cornstarch mix with the water. The warm is going to help it mix. All right, I'm going to take that cornstarch water and I'm going to place it in this Ziploc baggie. The plastic of this bag is going to act as our semi-permeable membrane. The question is, will this cornstarch water diffuse through the semi-permeable membrane of the plastic into the solution of iodine water? And that's filled about halfway. And to that halfway, I'm going to add 1 ml of iodine. To make sure my two solutions don't mix without seeping through one way or the other through the plastic, I'm going to tie a knot. Make sure this is pretty airtight. And then I'm going to submerge this cornstarch water into my water with the iodine. Like I said, the question is, will the cornstarch water pass through the membrane of the plastic and mix with the iodine water, or will the iodine water mix through the plastic or seep through the plastic and mix in with the cornstarch water? I suspect that the iodine water will work through the plastic into the cornstarch water. I make that guesstimate because I know that iodine is smaller in molecular structure than the cornstarch. I know that cornstarch as a polysaccharide is a macromolecule and it is larger in size than the iodine. And so I predict that the iodine will pass easier through the plastic than the cornstarch will pass into the iodine water. We are going to submerge the cornstarch bag into the iodine water and then wait 15 to 20 minutes and see what happens. The second part of this lab is to observe osmosis. We are going to be starting this experiment with an egg, which is going to act as our cell. And the first liquid we are going to test is white vinegar. I have 200 mLs of white vinegar and I'm going to pour it into this cup, making sure that my egg is entirely submerged in the vinegar. This experiment entails allowing this egg to sit in this vinegar for 24 hours. At the end of the 24 hours, we are going to observe any changes that have occurred with the egg, with the amount of liquid that is still in the cup. I used, 200 mLs is the amount of vinegar that we used. We are going to be looking to see if this vinegar is hypotonic, hypertonic, or isotonic. And we will know what it is at the end of 24 hours. We'll come back and observe the egg and the amount of liquid that remains in the beaker. Okay, it's been 20 minutes. We're going to check our bag of cornstarch water and see what has happened. All right, so it's easy to see there is discoloration in this bag. So that lets me know that the iodine water did in fact pass through the physical membrane, the permeable membrane of the plastic, and discolored the cornstarch water. We know that iodine is inside of this bag of cornstarch water because of the color change, because our cornstarch water was white and now we see a purpley dark color. So that means that the prediction was correct. We do know that iodine, because it is smaller, was able to pass through this plastic bag and discolor the cornstarch. Okay, this is lab 6 and day 2 of the egg experiment. Yesterday I placed an egg in 200 ml of vinegar. It's been sitting for 24 hours at room temperature. We are going to observe and record the process of osmosis with this egg and vinegar. Osmosis, the movement of water. So we are going to be observing whether water moved from the vinegar into the egg or from the egg out to the vinegar. So right away I can see there's a white foamy on the surface of the vinegar. So I know some sort of chemical reaction has occurred, and looking at the egg, it looks different. The shell on the egg is dissolved, mostly dissolved, and the egg feels rubbery, soft. It's yellow underneath of this filmy, which I'm assuming is the residue of the shell. So the vinegar the solution dissolved the shell, and I'm predicting that it moved into the egg itself, so that vinegar would be a hypotonic solution to the egg. If I look at my beaker, there is less vinegar in the beaker than there was yesterday. I filled the beaker to 200 ml, and there is, that's 150, there's 5, 10, 15, 20, 5 cc's, 5 mLs missing from the beaker. I dribbled a little bit, some is here on the paper towel, but that would lead me to believe that, again, water from the vinegar moved from the vinegar into the egg. Again, proving that the vinegar would be hypotonic to the egg. So next, I'm going to gently rinse this egg off, and we are going to submerge it in our second solution. Okay, we have rinsed off the egg, and now I have prepared a cup here, beaker, with clear Karo syrup, sugar syrup. I intend to put 200 mLs worth of syrup in here. I guess I'll top that off, because if I put the egg in first. So I know that the Karo syrup is denser than the vinegar, and I know when I put this egg in here, it isn't going to just drop to the bottom. It's probably going to take a while to sink. I don't know. Let's see. Well, it's going down faster than I thought, but it didn't go down as quickly as it did when it was in the vinegar. It's still floating here on the top. So I'm going to hypothesize that the Karo syrup is going to be hypertonic to the egg, and that the egg is going to lose water. It is going to flow out of the egg and into the Karo syrup, and that's what I'm going to predict will happen when we observe this egg 24 hours from now. tomorrow. Okay, we're back for the next part of our experiment, and yesterday I placed an egg that had once been sitting in vinegar, rinsed off, and now that egg that was soft and bouncy and swollen with the water that was pulled from the vinegar solution, I took that egg and placed it into 200 mLs of Karo syrup. I see now, looking at the egg, that it's shriveled up in appearance, and that right away kind of confirms to me that water has moved from the egg to the outside of its shell, and I'm going to predict that the level of Karo syrup is going to be above the 200 ml mark, because I believe that water has moved from the egg into the Karo syrup, making the Karo syrup hypertonic to the egg. So I'm going to gently lift the egg. Wow, it is very... Gosh, I hope I don't break this egg. I'm going to try to let as much of this syrup fall back into the cup, but easily I can see I made a red line on my beaker, making it easier to read the 200 ml mark, and I can easily see that the liquid in the cup is above the 200 ml mark. So again, water has definitely moved from the inside of this egg to the outside in the Karo syrup. So I'm going to take a moment, rinse my egg off a bit, and then move it on to the next solution. Okay, our third and final solution is distilled water. Distilled water is water that has had its impurities, mineral content removed by a process through steaming. So I'm going to take my egg that had been sitting in Karo syrup and place it in the distilled water, and it's going to drop right down to the bottom. So I am going to hypothesize that the water is going to be hypotonic to the egg. I think that the egg, that water is from my solution, my distilled water, is going to move into the egg. So that's my prediction. We'll see what happens tomorrow. Okay, we're back for the last day of this week's lab experiment, and I've had our egg sitting in distilled water, 200 mLs of distilled water, for 24 hours. Right away, looking at it, I can tell that there has been a difference in shape to the egg, which leads me to believe that my prediction that the water, the distilled water, would be hypotonic to the egg is true. Yesterday, the egg was shriveled, and today, the egg is back to being swollen. Reminds me of a couple of days ago when I pulled it out of the vinegar. It is squishy again, and wow, there is a lot of water missing from the cup here. So the water was filled to the 200 ml mark, 10, 20, 50, 60, 70. There's like over 10, 15 mLs missing from the cup. It's not missing, it's inside of the egg. So the distilled water was most certainly hypotonic to the egg after the egg had been sitting in Karo syrup for 24 hours. So that is the last step for this egg experiment, which ends this week's lab.